Hello world! Welcome back to another TryHackMe challenge video. In this video, we're going to be going through the Squid Game room. Let's get started. Task 1 is the scenario, so let's go ahead and read that off. You have an invitation to play a Squid Game. In this game, you will have to play the defensive role and eliminate 5 attackers. Let us tell you before the game starts, this is not going to be easy. Less hints are provided in this room to challenge you. You won't believe it, but sometimes the best way to learn is to do your own research and come up with your own approach to solve the challenges. You will have all the necessary tools needed in the virtual machine to complete the challenge. Alright, and give some other information here, and here's our first response. Accept the invitation? Yes. Or not. This? There we go. Alright, so if we kind of like scroll through these attackers, you'll notice there's a ton of questions for each. And I'm sure that each one increases in difficulty as we go. So what this is going to be is actually a 5-part series where each video we're going to tackle a different attacker for this whole room, okay? So in this video, we're going to tackle attacker 1. So let's go ahead and get started with attacker 1. Attacker 1 will give you a warm-up before the hardest yet to come challenge. Try to push attacker 1 outside the lines. Good luck. Alright, so the first question is already a doozy. What is the malicious C2 domain you found in the maldoc where an executable download was attempted? So if we come into our lovely Linux machine over here, we'll see that there's a maldocs folder. That's probably where we need to look. And we'll notice there's a .doc file for each of our attackers. Now, .doc is a Word document file, so that already tells me that we're going to be dealing with probably macros. And macros are just executable objects that are inside of Word documents. And a lot of times hackers can infect documents, Word documents, and that when they're opened, or if like something is like an element inside the Word document is clicked, it'll actually execute malicious code. So, that being said, let's go ahead and start solving the challenge. So we're going to go ahead and open up a terminal, and instead of white here, we're going to go ahead and change this to dark mode so it's a little easier on the eyes. Go to preferences, colors. Okay, cool. Now let's go ahead and navigate to our maldocs folder. Go ahead and ls. All right. Let's go ahead and tackle the first question. We're looking for a C2 domain. So they haven't really told us what tools we have available, but a suite of tools that is very useful for essentially macros analysis inside of Microsoft Office documents is called Olay tools. So if we type in Olay, like part of it, right, and we press tab a couple times, we can actually see the different Olay tools that were at our disposal to analyze this file with, right? Now, we'll be going over like what each of these tools do as they come up in the challenge. So we're going to start off with using Olay dump, right? It's going to analyze our attacker 1 document for streams. And each stream is like a component or like an object or just like a file essentially, right? Inside of our Word document. Word documents are literally basically compressed files of other files, right? It's like a conglomerate of certain files. So we're going to go ahead and run olay dump.py on our attacker1.doc file and see what we get. Probably take a second. So each of these numbers on the left represents a stream. And the nifty thing about Olay dump is that we can, and I'll go ahead and dump out the help menu, is that we can actually select a stream to analyze. And what we want to do is we actually want to use this strings function right here in tandem with our selected stream, because if we don't do that, then it'll dump out a bunch of hex and it's going to be a little bit more difficult to read, right? So we really just want the strings from it to see if there's anything fishy going on inside the file. And just for sanity checks, sanity's sake, I will go ahead and just run Ole dump on stream 1 of our attacker doc, just so you can see what it looks like if we don't use the strings argument. As you can see, it looks like that. So if we add the tac S in, the tac capital S in, we actually see it just purely just prints out like the readable strings, right? Just like the strings function. So now that we got that out of the way, let's go ahead and clear the screen. And let's run Ole dump again on our attacker 1 doc so we can see the streams. We notice that there's macro streams here, and one of those has our macros in it, which we'll get to later. But basically, we don't know what's hiding in any of these streams. Like, there's no real indicator what could be there. So we're gonna have to just go through each one until we see something that we want, right? Because basically, when we're looking for a C2 domain, we're pretty much looking for some kind of obfuscated data that has like, that decodes to something executable or whatever, and that'll have our C, because whatever gets deobfuscated is going to be executed and then call out to the C2 domain. So let's run oledump.py on each of our streams, right, and see what we get. Okay, nothing there. Nothing there. Nothing there. Ah, here we go. Take a look at this. There's a whole PowerShell blob here, right? And it looks like it's encoded in base 64. Now, the one problem I see with this is that, well, there's brackets in between some of our characters here, and I think that's there to further obfuscate the code so that we can't decipher it, right? So what we need to do is figure out what we need to do with those brackets, and we either need to replace it with some sort of base 64 character, right? Like one from the base 64 char set, or we probably need to remove it, right? So, and we can tell it's base 64 based off the equals here, and then, you know, it just kind of looks that way, right? Now, this is what I was talking about before. You see how this is going to be decoded, and it's going to have probably our C2 domain located somewhere inside of it, right? Because once whatever is executed decodes this, which is probably inside the macros, right? The macros is probably what's decoding this. It's going to execute that and call out to the C2 domain to probably download a file, right? Because this is probably going to be the dropper for our for whatever malicious executable it wants to infect the computer with. So let's go ahead and take that, and we're going to go ahead and fire up CyberChef, because I think that's on here. Yes. And we're going to run it in the background, I guess. Yep. And it's giving us a bunch of weird errors here for some reason. So what we're going to do is... oh, no. So let's go ahead and just close our terminal for now, and we have it copied, so oh, this is looking a little strange. Okay, so let's go ahead and paste our input in there, and we're gonna go ahead and do from base 64, even though we're not ready for it yet, right? Because we got to figure out what we need to do with those open braces. Now let's go ahead and bring back up our terminal, maximize it. We'll go ahead and go back to our mal docs, and the next tool we want to use is OleVBA, which is going to basically analyze the source code and try to deobfuscate it so that we can read it, right? It's going to, the source code of the macros, I mean, right? Which is what's being executed inside of our Word document. So if we run OleVBA on our attacker1.doc, we will get a lot of good stuff here, right? So now we're looking for something that has to do with our base 64 code. So if we look around for a second. Ah, here's something right here. You see this replace function right here? So it's taking something, right? Which is probably the base 64 code, and it's replacing all the open brackets with A. So this code is deobfuscating that PowerShell blob that we saw, right? So all we got to do is replace those open brackets with A. And that just took a little bit of analysis into this, giant mess of obfuscated code, right? But if you look close enough, sometimes you can find hints to something that you need to use to essentially reverse engineer what you're looking at, right? So let's come back here. Luckily, CyberChef also has a replace function. And we're going to use that first, right? And what we're going to do is maximize the screen so we can see everything. And we're going to say find, and we don't want regex, we want simple string. We want to find this open bracket and replace with an A. Ah, there we go. This is much better. So now that we seemingly have the plain text, right? We can see that we have like all these extra dots in here, right? And we want to get rid of those. What those dots represent are actually null bytes. So what we can do is actually in CyberChef, there should be a remove null bytes right here. And that'll give us the actual plain text we're looking for. So now if we come through here and we see we have a C2 domain right here, right? It even says download data, right? So this is where it's going to be downloading probably a malicious executable from. Or it's also where it's going to be communicating right back. So let's go ahead and submit that. All right, what executable file is the maldoc trying to drop? Well, if we scroll down a little bit more, we'll notice that there's a qdzgb whatever.exe. So that's going to be the answer to that one too. In what folder is it dropping the malicious executable? Hint. Okay, so we have to submit our answer, I guess, like that. So if we notice where the executable is getting dropped, it says system.environment get folder path common application data. So whatever this is going to be our answer, right? Because that's where the executable is getting dropped at, is whatever this is. So we can easily just take this, fire up a PowerShell prompt, paste that in, and we see we get seek program data. So now to confirm this, we can just do a simple little start R, and we can do mod program data, right? That like so, and we see it gets brought up. So now we've confirmed that that is probably our answer. So let's go ahead and type that in, mod program data mod, and there we go. So provide the name of the COM object the maldoc is trying to access. So I have a feeling that's probably in here, but there's actually not too much to this file, right? And I don't really see anything that says COM object, right? So let's go ahead and do a little research, okay? Since we don't know what this is. COM object. The term COM object refers to an executable code section which implements one or more interfaces deriving from IUnknown. IUnknown is an interface with 3 methods which supports object lifetime reference counting and discovery of additional interfaces. Every COM object is identified by a unique binary identifier. Huh. Okay, that's interesting. A unique identifier, huh? Let's do a little more research, all right? Wikipedia is always reliable. So COM is a binary, Let's see, where do we want to go? Let's go to technical details. COM programmers build their software using COM-aware components. Different component types are classified by class IDs, CLS IDs, which are globally unique identifiers, or GUIDs. Oh. So if we click that, hey look, there's an option in COM, and we notice there's that CLS ID again. And if we come here, I believe we saw a variable called CLS ID. And there's a GUID for it right there. So maybe this is the COM object we're looking for, right? Because we know COM objects are related to CLS IDs, which are GUIDs, right? So let's copy this. I don't have a fancy way of converting, or I guess looking up what the matching object is to the GUID, right? So let's just see if Google has a default value for us. What is com object CLSID? That's probably good. Let's take a look. And okay, there. I hear something. I didn't see that before. It says, please note that is the class ID for shell browser window. Okay, so this GUID we looked up is the class ID for shell browser window. I'm sorry, I didn't read the description before I clicked the link, but and here's the bullet point right here that says it. Okay, so this is probably the answer we're looking for, isn't it? So let's go ahead and submit that. Awesome. All right. Include the malicious IP and the PHP extension found in the maldoc. Okay, well, here's another one. Let's see. I think I saw it up here. Yep. Here's our IP address and our PHP extension. It looks like it just wants the IP address. So no HTTP at the beginning. We'll take that. Paste it out. Another correct answer. All right. So looks like we're switching gears now. It looks like we've gotten all the answers for what's inside this malicious document. Inside that. What we were just looking at is the dropper. The dropper is what communicates with the C2, and it'll ask the C2 for, or get the malicious executable to run from the C2. Our next question is find the phone number in the maldoc. So we don't need this anymore, but I'll go ahead and minimize it just in case we do. Let's go back to our terminal window and let's go ahead and clear. Okay. Now, if we look at our Olay tools, we'll notice that there's Olay meta. And what Olay meta does is extracts all standard properties present in the Olay file. So what it does is it extracts all the metadata, right? So let's go ahead and run Olay meta on our attacker1.doc. And we'll see a bunch of information here, and I see a phone number right here. So let's go ahead and take that phone number. Correct answer. All right. Doing some static analysis, provide the type of maldoc this is under the keyword auto open. If you remember when we ran Olay VBA, there was actually a section underneath with a table. And I think I remember it having the column header keyword under it. So let's go ahead and run an Olay VBA again on our attacker1.doc and see what we get. Here we go. I was right. There's a column header that says keyword, and there's our auto open right there. And right next to it, it says auto exec. So that is the type of maldoc that this is associated with. And if we look at the description, it says runs when the Word document is opened. So our malware will literally run when this document is open. A lot of times the malware only executes, or the macros only executes in a Word document or other Office document, right? When you click a clickable item, right? Or object, like a button. But in this case, this malware will execute, or I guess the dropper we saw earlier will also execute when the Word document is open. That's very dangerous, right? Because that means you have no leadway. As soon as you open that document, it's lights out, unless you have, of course, third-party protections on your computer that can prevent it. Provide the subject for this maldoc. Make sure to remove the extra white space. All right, so subject sounds like more metadata to me. So let's go ahead and rerun our Olay meta on our attacker1.doc. And here's the subject right here above where the phone number is. And it said remove the extra white space, so, okay. Provide the time when this document was last saved. All right, so the thing is, we do have a last save time right here, right? So let's go ahead and try that first. Incorrect. Huh. Well, that's to be expected. A lot of times, well, times, right? A lot of the time with tools like these, they don't get the most accurate measurement of time that's required, right? And sometimes the time is actually spoofed by the attacker or the macro, right? So what we need to actually do is there is a tool, and I'll go ahead and clear. There is a tool called Ole Times, and that'll give us more accurate times than the other tools will, right? Because some of these other tools will actually give us the same information that we could have put in before, like Ole Dump and Ole File. Those will all give us the subject and phone number equally, right? Depending on how we set it, or, you know, depending on what arguments we use. In fact, I think you even saw those when we were going through the streams earlier with Ole Dump. But Ole Times will actually give us more accurate time measurements. So let's go ahead and run that on our attacker 1. And as we can see here on this root modification time, there's actually a 30 right there, right? Which was missing before. So that's going to be our actual answer to this. All right, last 2. Provide the stream number that contains a macro. Okay, remember we're dealing with streams, so what's the best tool we use? Ole Dump, right? So we're just gonna go and look at the same output we looked at before. I'm not sure why they made the easier questions come after the harder questions, but it's fine. Anyways, attacker 1. Okay, and we're looking for the stream that contains a macro. So any stream that contains a macro will be designated by an M. Okay, so stream 8 is the macro we're looking for. So that'll be our answer. Provide the name of the stream that contains the macro. Well, the name is out to the right here, but it looks like it only wants the last bit of it, this document portion of it, right? Because this is the answer format does not match the length of this whole string right here. So let's go ahead and take that. And that's it for attacker 1. I hope you enjoyed the video. Drop a like, subscribe to the channel to show your support. Check out our Patreon and Discord links in the description box down below, and leave any feedback in the comment section down below. This is Almond Milk, and I'll see you in the next video when we tackle attacker 2. Thanks for watching.